All right, welcome back to Recommended Daily Value. Today, we are going to be doing a deep dive with Kathleen Stewart into cholesterol. So Kathleen is a cholesterol sterol expert, and we're just going to kind of be going through a lot of like what the mainstream consensus is, give you guys a little bit of background and basics for the foundation, and then kind of go into our individual takes.
Sounds good.
Cool. So cholesterol is a sterol, which is a type of molecule, and it's a precursor to all steroid molecules, including hormones like testosterone and estrogen, vitamin D, bile, which is used in digestion, and it's also used in cell membranes, which may be a point of contention. We can come back to that later. Probably not too deep into too much of a worry for the cholesterol argument itself. Cholesterol is synthesized endogenously in the body and absorbed through food. How much someone absorbs of cholesterol can be as low as 25% and as high as 80%. However, dietary cholesterol only accounts for a small percent of how much cholesterol you're actually absorbing, so it's about 20%. Cholesterol is made through acetyl-CoA, so it's a byproduct of metabolism, meaning that cholesterol is made from proteins, carbs, and fats. The liver and intestines produce most of cholesterol, about 80%, but all other organs do produce it in small quantities. Now, when most people are discussing cholesterol, they're not really talking about cholesterol. They're talking about HDL and LDL cholesterol, which are lipoproteins that carry cholesterol, triglycerides, among other fatty substances to and from the liver. LDL is commonly referred to as being bad. HDL is commonly referred to as being good. LDL carries fat to all the cells, to all the organs away from the liver, away from the intestines. HDL carries it all back to the liver. Anything you want to add there?
No, I think that's a great summary so far.
Okay.
I think the big thing, what you were saying about cholesterol from the diet is that, so like you said, there's a big difference between people, and that's where you get into like the familial, like hypercholesterolemia issues. And then the other thing is that when we are making less cholesterol endogenously, then there does seem to be a feedback that allows the intestines to absorb more cholesterol. So we get more cholesterol from food. So, if lowering cholesterol is a concern and you're using something like a statin to lower that, which of course we can discuss that later, then you still need to be kind of concerned about you need to be more concerned about the cholesterol from your food in this case versus if you were just kind of relying on endogenous cholesterol. Because again, it kind of goes back to this like threshold or equilibrium point where once you have met that point, then the body's like, okay, we don't need to absorb as much from food. But if you're not at that point, then the body's going to be like, we need to absorb more from food.
Yeah, and that's also kind of going off if you were to, like, what you're saying is there's kind of a balance point or a homeostatic point, and that's probably going to be different person to person. But if you just cut all the cholesterol in your diet, you may end up just producing a lot more if you're in a good state.
Exactly. Yeah.
And vice versa too. So if you have high cholesterol, if you have low cholesterol, you start eating a ton of cholesterol, your cholesterol may not change.
Right. Well, if anything, if you're eating more cholesterol foods, then you should be absorbing more. But again, there's always the difference person to person. And so you might not absorb more depending upon your own transporters, etc.
Yeah. And what the point of that is sort of saying is that the cholesterol absorption isn't static, even though it does vary largely person to person.
Right.
Yeah. So I did want to give a little bit of a background as to how we got here and where the mainstream consensus is as well, in terms of, in addition to just like the physiology of it. So in the 50s, physiologist Ansel Keys became a rising figure in America's public health scene after he discovered cholesterol in the arterial plaques of patients who suffered heart attacks. I think he actually worked on mice mostly. So Keys hypothesized that cholesterol caused heart disease, and to reduce heart disease, we needed to lower cholesterol. So this is a very contingent relationship. Heart disease is caused by cholesterol, reduce heart disease by lowering cholesterol. Keys conducted the infamous 7-country study, which looked at the incidence of heart disease around saturated fat consumption and found that countries with lower saturated fat intake experienced less heart disease. Keys then became close to President Eisenhower's doctor, Paul Dudley White. Eisenhower went on to suffer multiple heart attacks and renounced saturated fats as the culprit for heart disease, likely in influence of Keys and Dr. White. In 1960, Keys was appointed to the AHA, America's Heart Association Nutrition Committee, and by 1961, the AHA rolled out its nutritional guidelines to minimize saturated fat intake to avoid heart disease. Between Eisenhower's heart attacks and the AHA's recommendation, the public consensus on the causatory role of saturated fats in heart disease had taken over. So there's a couple issues with Key's diet-heart hypothesis and his research, which is one, it is following the line of thought that high cholesterol causes heart disease, and two, that lowering saturated fat and cholesterol intake will lower cholesterol levels, therefore lowering heart disease. The few issues here is that, and with the studies that follow it, is they assume that cholesterol levels are a proxy for heart disease. Lowering saturated fat intake is a reliable way to lower cholesterol, at least in the short term. But as we find out, lower cholesterol or lower saturated fat does not inherently result in less cardiovascular disease. And two, they overlook all-cause mortality. So if you find out that lower cholesterol levels results in less heart disease, this only matters if people are living longer. So if someone just dies from something else, now people are dying from cancer instead of heart disease. We're not overall living longer. We haven't really solved the issue. We've kind of just traded. So then years later, we'd find out that Ansel Keys' data didn't hold up to scrutiny. He cherry-picked a bunch of the countries to fit his bias. A bunch of research has come out since. The Framingham Heart Study found no relationship between saturated fat and heart disease, and found the more saturated fat one ate, the lower the person's serum cholesterol, which I don't know. Do you agree with that?
I think there's so many topics here. I'll let you finish and then we'll start discussing. Yeah.
Okay, cool. The largest test of the diet-heart hypothesis, the Minnesota Coronary Survey, involving 9,057 men and women over 4.5 years, tested a diet of 18% saturated fat against controls eating 9%, yet we did not find any reduction in cardiovascular events, cardiovascular deaths, or total mortality. So that's saying that they had a control of more saturated fat versus less, and they didn't find any difference. And then not to mention the AHA was funded by Procter & Gamble, who makes Crisco, which has been going for the last century as the heart healthy oil. So where this leaves us, still a large amount of associational evidence demonstrating a relationship between high cholesterol and cardiovascular events, which we'll discuss. But low cholesterol levels are also associated with a higher risk of cancer and autoimmune diseases. So probably don't want to have very high cholesterol, but low cholesterol is also not a good thing. Replacing saturated fat with polyunsaturated fat does lower cholesterol in the short term, but saturated fat does not appear to play a causative role across the lifetime in higher cholesterol levels or cardiovascular events. The biggest indicators of heart disease include high blood pressure, high cholesterol, diabetes, and smoking. All of these are, except smoking, are very related to the metabolic syndrome, obesity, central adiposity. And essentially, it means that you kind of have a lot of traffic building up in your bloodstream and things are not flowing smoothly. Unlike what your doctor may tell you, cholesterol is important, but you don't want too much of it. And yeah, let's dive in.
Okay. There's a lot here. So first of all, Ansel Keys, obviously in some regard, I'm a fan of him because he was the principal investigator for the Minnesota starvation experiment.
Did not know that.
Yeah. It was just crazy. And then he does this as well. So, I think this just goes to show you that that science is not, there's faults in science, right? And I think that I'm not saying that all of his saturated fat research is all faulty, but I definitely think that we agree that there is some faults in it and things that are worth exploring a little bit more. Especially, I think what kind of started this all off is that we were talking about the testosterone production and about how the research, or many people claim that if you increase fatty acids or fat intake, that you tend to see a rise in testosterone production. And I push back on that in terms of the cholesterol pathway, right? Because like you said at the beginning, cholesterol can be synthesized from any acetyl-CoAs. We can make acetyl-CoAs from any of the 3 micronutrients. So it's really not dependent upon the fatty acids themselves coming in. Now, we've also kind of talked at length about, okay, is there something more specific to the fatty acids and like testosterone production, like maybe related to the PPARs, which have to do with, there's alpha, beta, and like gamma. Sometimes they change the name of gamma, but like signaling with the PPARs. Or is there something more specific to, the fat composition, like so the PUFA versus MUFA versus saturated fats, and again signaling. Is there something more specific to, okay, when they went to more fatty acids, they're getting more fat soluble vitamins and or more minerals like zinc, because okay, now we're eating more ground beef, and so we're getting more zinc and iron and B vitamins and all that stuff. So it's a more micronutrient thing. I think there's a lot there, but I think again it just goes back to this like foundational premise that once cholesterol has pretty much been accounted for, now what the body does with the cholesterol, this becomes a whole different conversation, and I think something that we're discussing here. So like you said, there's, different sizes or forms of that cholesterol will then be transported in the body. A lot of people, I don't think, realize that chylomicrons is a big one. And so chylomicrons is basically how we pick up those longer chain fatty acids from the digestive system. And they're big, right? And they go through our lymph system. So most of the longer chain fatty acids go through the lymph, and then they go into the circulation, through the main vein through the heart, and then into the circulation that way. And they're the most, they're the largest, but the least dense, because they're only 5% protein. So basically how they classify the density and the size is the more protein, the more dense, and then smaller size, right? Because less fat, so the fat would be bigger. And the reason for the protein, the structure, the protein basically acts as a structure. And so you'll hear like ApoB, ApoA, ApoB100, like all of that. And those proteins are acting as the structure for the lipoprotein, or the LDLs, the HDLs, like all the lipoproteins. And so it's the structure, and then it's also what allows those HDLs, LDLs, those particles to then actually like interact with the quote unquote receptors on like the hepatocytes, so the liver cells, or like, the adipose cells, like any cell basically to basically react with it. And then it also, because again, fats are hydrophobic, so they don't like water, they're not hydrophilic. For them to stay dissolved in serum or even in the cytoplasm, they have to have something that makes it more hydrophilic. And so that's what these structural proteins do. They basically make it more hydrophilic. So you have the chylomicrons, again, they're the least dense, only 5% protein. They are basically all triglycerides, because again, it's pretty much pulling the fats that you're eating, the big fat, the big chain, or the long chain fats that you're eating from your diet into circulation. And then also, they're also there in the lymph, basically taking cellular cleanup and stuff after the cells have done things, and taking it through the lymph, back to the liver, et cetera, for export. Then you have the VLDLs, so the very low density lipoproteins, and they're the next. They're not as large as the chylomicrons, but they're a little bit smaller, but they're bigger than like HDLs, and then after that, you have the intermediate LDLs, and then the LDL, and then HDL, which is about 40% protein. And, people classically look at like HDL as the good one, but I think research continues to show that, like, again, back to this threshold idea, that more HDL doesn't really mean like better health. And if anything, I kind of look at HDL like, if you had high HDL, so it's basically LDL is transporting, like leaving the liver. The liver's like, I have basically too much fat. I don't want to store it all because I don't want to get fatty liver, basically. Get out of here. And also, like, it's needed too, because the cells peripheral to the liver obviously need fatty acids to make ATP and cholesterol for their quote unquote cellular membranes and all of that stuff. So they need some amount of fat. But HDL is then the periphery basically being like, we have too much, send it back to the liver. And again, to like a threshold, I think that's important, because the liver can then take the cholesterol from the HDL and basically just send it to feces or for bile production. And then, use the trigs and stuff to actually make ATP in the liver using the fatty acids from the triglycerides. But again, at a certain threshold, I see this as a problem, because what happens when the liver is overwhelmed and it can't do those things, right? And so now it's just like, well, I guess I have to store it. And so, that's why I think after a certain threshold of HDL becomes a problem too, because then you're still running into this issue with non-alcoholic fatty liver, et cetera, et cetera, et cetera. So,
do you see high HDL in non-alcoholic fatty liver disease?
I don't believe so. I don't know. That's something, let me look up that.
Because that would be interesting, right? Because essentially what you're saying is, you know, you would see probably high HDL because there's just too much fat. Liver's trying to get it out, but then there's high HDL, which is because your body's, for whatever reason, not able to process the fat. It's sending it back to the liver. So theoretically, I think that would possibly make sense.
Yeah, I agree. It says that no, that typically you do see low HDL.
Okay.
Let's see. I mean, I could see eventually when someone having. I think probably the reason why you see low HDL is because the liver at that point is struggling so much that it can't even make the structural proteins in the first place, because it makes. I think HDL, the structural protein, is APOA, I'm pretty sure. And so the liver's making that, and then it puts it out, and then it's kind of this like disc shape. And then as it like basically fills up, it becomes more spherical and stuff. And so if it can't even make that original structural piece, I think that's, you know, kind of stepping back. The structural piece, the enzyme piece, is the huge like missing conversation in so many things when it comes to the body, because like it's all well and good to have all of these things, like it's all well and good to you know, take exogenous hormones or whatever, but like if you can't make the receptors, quote unquote, for the exogenous hormones to then actually interact with, then it doesn't matter, right? And this is why you see, you know, a fair amount of times where people will start things like TRT or even like high dose testosterone or, you know, progesterone, etc., and like they get really no response from it, and that's the reason why. So yeah, I think back to the HDL conversation, I think the liver would probably be just under so much stress at that point, and like not like so much stress, and then also just like so many conflicting messages, because you have like high everything, you know, like everyone loves to just talk about insulin resistant and you know, not being sensitive to glucose, but like literally you're not sensitive to anything and you're resistant to everything. So insulin, glucagon, like everything at this point, cortisol, you know. So I think the liver is probably just like, I have no clue what's going. It's kind of like Lucy in the chocolate factory, where like everything's just coming at her, and she's just like shoving it in her mouth. She's like, so I can imagine that's probably the liver is like, I just give up, like at this point, like So that's probably why you don't actually see the high HDL. Now, talking about regulatory stuff though, so most of the cholesterol, like you said, it's synthesized in the liver, intestines, kidneys, gonads, and adrenal glands. That's where like most of the cholesterol is synthesized in the body. And then obviously every cell can make it, but like you said, like the most amounts of it. But like cholesterol and synthesized in the cytosol, most of it, except for if it's in the mitochondria, then it can be used to make ketone bodies. But when it's in the cytosol, it is causing a negative feedback. And so for the people that have high cholesterol, my big like wonder, and kind of looking at this from like a more of a cell structure thing, is so cholesterol is obviously, well, it's a fat, right? It's made up of a bunch of fats, right? And fats, again, are hydrophobic. And pretty much once you hit the squalene step, so there's the mevalonic or the mevalonate pathway, the initial pathway to eventually get to squalene. And then from there, you get to lanosterol. And then from like lanosterol to the cholesterol, there's like 18 or so steps. We're kind of fuzzy, to be honest, on how many actual steps there are. But basically, you go from lanosterol to cholesterol. And then cholesterol is supposed to have a negative feedback to the sterol. It's the SREBP. It's the sterol regulatory element.
Dioxodosqualene.
Squalene. Squalene, then to lanosterol, then to cholesterol, and then so cholesterol is supposed to have a negative feedback to the sterol regulatory element binding.
Okay,
proteins.
like it was SBREP.
SREB.
Okay, I've seen that before. I had no idea what it was.
Yeah, and then that basically causes a negative feedback on HMG-CoA reductase. So that's the like, you know, kind of big feedback part of this, the big control part of the, you know, cholesterol production. But anyway, so basically, to sum this up, cholesterol is supposed to inhibit its production. So if you're making a ton of cholesterol, why is it not inhibiting its own production, right? That becomes the big question, because it's supposed to be. That's what's supposed to happen.
So you're saying in the cells, why? So you're saying high cholesterol in the cells should signal backwards to the livers to stop making so much.
well, it's signal to the cell itself that's actually making it. So say the hepatocyte, say the liver cell is making the cholesterol, or the, the cortex of the adrenal gland is making the cholesterol. It should be signaling in the cytosol back to this HMG-CoA reductase, the enzyme that takes HMG-CoA and makes mevalonic acid. It should stop that process from happening. So, but why is it not, right? Because so many people have really, really high cholesterol, and it's like, well, why is that not happening? And I very much almost wonder. So again, and then back to squalene. So squalene in order, because there's so many fats there, in order for these compounds to stay dissolved in the cytosol, in the water, basically, they have to have carrier proteins. And so then the question becomes, are there enough carrier proteins? And if there's not, like, is the cell just like dumping the things? And so it always seems like, oh, I'm actually deficient in the cell because I don't have enough carrier proteins to keep these things in the cell. So it always looks like I'm deficient. But then you wouldn't see cholesterol necessarily go high in serum. So it's probably not that. Or is there something to do with the cell structure itself, where maybe the cell is now more water-like? So even if you are producing sufficient cholesterol and the cholesterol carrier proteins in the cell, because the cell is now more water-like, because it's less structured, so it's more swollen, basically. It's basically just like I can't stay in here. I'm not meant to be in here, and it just leaves. And so it's just every single time it makes cholesterol, for whatever reason, it can't stay in the cell, so it just leaves. And then the cell's always like, hey, I'm deficient in cholesterol. Like, I should be making more and more and more. I'm deficient. And that's the reason why. Or is it something more like, again, when we're in this state, when it's like really high cholesterol, and we basically don't see everything because it's like, a 4-alarm fire, like everything's just fire all over the place. And so you don't have any kind of this like signaling feedback type thing.
Do you think, go ahead.
I was just going to say, it should all be signaling. Yeah, it should all be feedbacking on itself. Go ahead.
Okay. Do you know how cholesterol has a direct relationship in the cell, in like the membrane, with how much PUFA versus saturated fat is in there? So that I believe the relationship is more saturated fat, less cholesterol is needed, more PUFA in the cell membrane, the higher cholesterol. Is that correct?
I think that's correct. Yes, because the cholesterol is there to help maintain the fluidity. So if there is more PUFA, the cell membrane would be more fluid, so you would need less cholesterol. But if there's more saturated fat, then you would need more cholesterol to keep the membrane more fluid. Yeah.
So based off of what you just said, like, it would kind of make sense. I'm just kind of spitballing here.
Yeah.
That like cholesterol is just shunted out to the back of the cell. So maybe in the cytosol, there's not that much, especially in this disordered cell that's very watery, not very structured.
Right.
That cholesterol is not actually being able to downregulate the HMG-CoA that is downregulating its production, because everything is disordered.
Yeah, exactly. Well, and then so like that's the cholesterol feedback into HMG-CoA reductase. But then there's also glucagon and AMP. So glucagon and AMP is basically a signal of the not fed state. And in the not fed state, like the body is like, oh, I shouldn't have enough to make cholesterol, so you should be stopping HMG-CoA reductase because we just can't make more cholesterol because we just don't have much stuff. And then in the fed state, so in insulin, in that case, the body's like, oh yeah, I have enough. I should be able to make cholesterol. And so insulin should be signaling to make more cholesterol. And then the other thing is the statins, they basically resemble the mevalonic acid. And so because they resemble the mevalonic acid, the body's like, oh, we have way too much mevalonic acid, so we don't need to take the HMG-CoA through HMG-CoA reductase to make the mevalonic acid. So so it's just like, we don't need this anymore. So there's all of these like feedback loops. And then the other thing too is that cholesterol production requires, first of all, a ton of ATP. And that's potentially a problem for people because of, well, we discussed this, but like micronutrient deficiencies, like just eating enough in general, all of that stuff, sunlight, like all that stuff. And then it also needs a ton of NADPH, which is interesting because a lot of people love to talk about like NAD to NADH. And I love talking about that too, right? The ratio of NAD plus NADH. But a lot of the times the pentose phosphate pathway is left out of these things. And the pentose phosphate pathway is what makes NADPH. And that's like the terminal, the pentose phosphate pathway and NADPH is like crucially important, not only here for cholesterol synthesis, but also for we've talked about this before, but the antioxidant cascade. So, you basically have vitamin E to vitamin C to glutathione to NADPH, and then you have like things off of it as well. But like that's the big path. So, the pentose phosphate pathway is crucially important, and pentose phosphate pathway pulls glucose 6-phosphate basically from glycolysis, the 10-step glycolysis, to go into the pentose phosphate pathway. So again, this is why glucose is crucially important. And again, you need, plenty of micronutrients for the pentose phosphate pathway, like you need TPP, so thiamine pyrophosphate. You need obviously B3 to make the NAD in the first place. So I think that could be, a potential reason here. You also need, again, sufficient coenzyme A at the very beginning of the cholesterol synthesis pathway, and like throughout as well. And so that, coenzyme A production, so alpha lipoic acid, vitamin B5, cysteine, ATP, like that, plays a role here too. I'm just trying to think, because there's so many people, like, yes, high cholesterol is like a big issue. Everyone's talking about high cholesterol, but I know a lot of people that have had low cholesterol.
Can you speak to that as well?
Yeah.
And say what you told me a few days ago.
Yeah, so I just view low cholesterol as, again, very indicative of a low energy availability state, because whether, again, it's an actual low energy availability coming from, overall calories and macros, or low energy availability coming from micronutrients, it is something is missing, because you're not able to make sufficient, acetyl-CoA, and then also all of the micronutrients, and plus all of the proteins needed for these enzymes in order to eventually get to cholesterol. So if someone has low cholesterol, I think that is a unless there's like something else going on, like they're, taking a statin and like they're like really driving it down, or like, I really think it's a big kind of clue that, like, okay, maybe we need to look into the LEA, a red S type situation. And we've talked about this before, like red S can be confusing because people think that red S, relative energy deficiency of sport, can only apply if you're like training like an Olympian. But like, you have to understand that like your threshold is here. And if you're like doing more than your threshold, and for some people it doesn't even have to be that much more, right? Then it doesn't matter if you're doing what you think to be like insufficient activity.
Yeah.
Like if you're doing more than that threshold, then you're going to put yourself in a red S state. So yeah, is there anything more you wanted to add to that?
No. Are red S in your eyes and LEA interchangeable?
I think so. I would say for the most part, yes, but I do believe that there are points where enough sleep and enough calories, so 43 to 48 plus calories per kilogram, is still not sufficient for the amount of training or amount of like movement, and also not only movement but like cognitive tasks too, because that's the other part. So we've talked about the LEA, we talked about red S, and I think eventually one day someone will describe like the cognitive energy demand as well, and I don't think that's been well described, to be honest. But so there's also that factor involved as well. I mean, I think people kind of like skirt around that idea with things like, stress being involved with all-cause mortalities, like psycho-emotional things, like, being crucially important to health and stuff. And so we kind of like skirt around this more in the like psychological fields of things, but not necessarily like fleshed out in like mechanism. I mean, mechanisms would just be like the stress pathways and stuff, but like, like not as like fleshed out as like the LEA, the red S state, like all of that stuff. So
yeah. Okay. So
I know that's like all over the place, but
No,
I think this
no.
entire topic is like all over the place.
Yeah. I mean, cholesterol is so fundamental to so many things.
Yeah.
So I'm not trying to demonize Ansel Keys. Yeah. Apparently he did a lot of other good work. But do you agree with, there's just like it's interesting where the carnivore community disagrees. And I used to agree with them at this point. But there's seemingly, and I haven't gone through a ton of it, just an overwhelming amount of evidence that points to high LDL being a risk factor for heart disease. Do you agree with this?
Yeah, so again, I think this is where looking at, again, the differences between VLDL, ILDL, and like actual LDL is the thing. So LDL can, again, go back to the liver, and the liver can like take it apart and stuff, and then again get like actually use those triglycerides, etc. And the other cells can use them too. But whether the LDL is causal or it's just like at the scene of the crime, you do see high LDL, but just like you see high everything though. So again, I don't, you know, I guess I'm still kind of like agnostic about this debate, to be honest. Like, I think we just need more information because, you know, if you were to give a perfectly healthy person and just inject them with a bunch of just straight up LDL, would they all of a sudden get, you know, coronary issues and stuff? Like, I don't know if there's ever been research showing that. That would be interesting to read if there has been. But when you're in this state, when you have high LDL and, you know, metabolic syndrome, again, it's not only LDL, it's lactate, it's
Yeah.
glucose, it's, you know, it's everything. So the entire body is, again, like, what's going on? Like, the cells are basically starving in a way, because whether it's a transport issue, a utilization issue, whatever, basically they just can't get things through. Back to the chocolate factory idea. But you have all of this excess stuff just like floating around the bloodstream, the lymph, in fat, you know, in fat stores, like in the liver, in the muscle tissue, right? Like you see the fat infiltration of the muscle tissue and all of that. So I am still, you know, I don't have a yes or no answer when it comes to, do I believe that LDL? Now, do I believe the answer is then just lower LDL, as, you know, by basically like lowering cholesterol? So basically like statins.
Just take a statin.
Yeah, I don't think so, because you're still not addressing everything else, right?
Yeah.
Like, which is why I think, you know, that's why the statin trials, like they use the relative ratios instead of the absolute ratios. And if you use the absolute ratios, it's nowhere near as impressive. It's like, I don't know
Relative ratio of what?
Of like the effectiveness of you know, if you're going to have like a coronary event, you know, down the road and stuff, like basically this is what a lot of people will do, is they'll use the relative ratio and they'll say like, oh, you know, this X medication or, you know, whatever led to X amount of decrease in like 40% of people or something, like, you know, or 40% of decrease or whatever. And it's like, okay, but if you actually look at the absolute ratio, it was only from like a 2.5 to like a 3.2% or something like that difference, right? And so you have to always look at the absolute versus the relative. And maybe that absolute 2.5 to 3.2 for some people, maybe that is like enough. But again, you're still not actually addressing the point, or the issue, which is again why even if you take a statin, then a lot of people still end up diabetic or have Alzheimer's disease, you know, all of these other things, because you're still not addressing the 4-alarm fire.
Yeah.
Like, okay, so maybe we go from a 4-alarm fire to a 3-alarm fire, but like we still have a massive fire going on, and we haven't addressed all these other things. So yeah.
Let me phrase this question in a different way.
Okay.
To the carnivore proponents, if my blood work is healthy, but my cholesterol is, let's say, on the higher end, do you think that's fine?
You know, there was just that study that just came out, and it's been kind of making its way through Twitter and stuff and the social media world. And I still don't think so. They call it the lean mass hyper responders or whatever.
Oh, yeah, I've seen. Okay.
Yeah. I think, you know, I think if you take away some parts of the study, people could argue like it's no different. So if you're okay with no different, then fine. But if you then address the issue, and you know, again, like we've talked about this at length, like overall, I find that people do better when they keep fats closer to this 0.8 grams per kilogram of body weight or so. Again, depends on body fat percentage. So, and some people, they do a little bit better, slightly higher. Some people, they do a little bit better, slightly lower. But for, you know, a vast majority of people, I find that to be a pretty good like baseline starting point. And then, you know, you adjust from there. But, you know, even when it comes to things like endotoxin, like we know that saturated fat brings in endotoxin. And people will say, oh, you know, they try to like justify it and say, well, it's protected with the saturated fat and the chylomicrons and stuff. But it's like, okay, but it's now in you, right? Where before it was in your intestines, which is technically external to you, but now you've brought it into you. And like, there's a problem with that, you know? That doesn't mean that I think that PUFA is the answer. But in general, I find that people tend to do better over time if they keep fatty acids or fat intake on the, you know, I consider 0.8 to be moderate. I don't consider that to be low at all. Obviously, people in the low carb keto realm would very much disagree with me.
Yeah.
And I understand that. But yeah, I just think, in general, there's a lot more research that needs to be done about the actual, like, in a healthy individual, if you pump them full of LDL, like what's going to happen,
Mhm. Yeah. So my conclusion essentially is like, and very similar, because what you're saying is cholesterol is probably a warning sign. High cholesterol is probably a decent warning sign of like other things going on that we should probably look into, right?
Right.
So my conclusion is that like high cholesterol, and this is kind of like basically what we say all the time, but like you're gonna have high cholesterol, you're gonna have high blood sugar, you're probably gonna have high insulin, possibly high glucagon, all of these things. It's basically a traffic jam in your blood. And so essentially, high cholesterol, because it can probably be synthesized by all of the macromolecules, is probably a result of kind of somewhat a caloric surplus. But I don't mean that in the absolute sense. I mean in the relative sense, as in you're consuming more calories than you're able to burn. So you just have this buildup of literally energy, but also other things over time. And we want to figure out a way, probably, possibly lose body fat at some point, probably for a lot of people, because that'll help clear out some traffic. But probably first to build up that actually your energy reserve, so you're able to match where you're consuming to where you're burning, and then hopefully take both of those higher. So burn more, consume more,
Exactly.
and then at some point do a calorie deficit, which is what we're literally in the middle of with the Transform group.
Yeah, I agree. And a big part of that is putting on muscle mass. Like, I think that, I definitely agree with this kind of push that there seems to be in the popular culture right now of like putting on muscle. I think that is crucially important for all of this. So, yeah.
Anything else you think we need to cover? I did have a couple. I want to talk about statins a little bit, but is there anything else that you want to point out, or anything you disagree with what I said?
No, I think overall, I think we're overall in a good agreement. I think the thing with cholesterol, the big question is, okay, you have high cholesterol, but your hormones are in the toilet. Like, okay, why is that happening? And that, I think, goes back to what we were just talking about how there is something going on with signaling. And so there's some communication issue or not a communication signaling issue, but there's a transformation issue. So we go from cholesterol to, making pregnenolone, and it's like, okay, why can we not make pregnenolone? And, so addressing the micronutrient side of that, if that's the cause, that would be the first thing. And the signaling issue, again, that also goes back to the micronutrients and just making ATP in general. And then, back to sufficient protein. And, I would say that the world that we're in, there's been a big push and focus on protein. And if anything, I think they've gone a little bit too far with how much protein they're like pushing down people's throat and stuff. But in like the general world, a lot of people don't eat enough protein.
So,
they're like,
yeah, I was talking to, when people think they like protein, they just think protein shakes. I'm like, first of all, it's not that much protein. Yeah. Second of all, you're not getting, most people are not getting enough protein.
Right. Yeah. So many people are at like, 50 grams. So many women are at like 40 grams. And it's like, that's not enough. So I think starting to address those things. And then of course, like I said, there's like this kind of mushiness when it comes to like the conversion of lanosterol to cholesterol, and like, those rings and stuff like that. It does seem like there's a light component of that too. And so that goes back to, I understand that we live in a world where it's like so easy to just be like, okay, well, just pop this supplement or pop this medication or whatever. But it's like, there are some kind of like foundational things that we just have to do in order to be like human. And, maybe we can mimic that inside and stuff, but maybe we can mimic it with a supplement or whatever, some type of gadget, but I still believe that you're missing something that we still have not quantified by doing that, and or you are missing something in a field like manner, right? In a like, so you have the food matrix, everything working together in the food. You have the sunlight matrix, like everything in the sunlight actually working together, plus it, working off with the surfaces because the sunlight is being absorbed, reflected, transmitted, etc., and it's being changed because of that. Plus, how it's being changed with like when you're in nature, like how it's, again, reflecting, transmitted, etc., off of the leaves, all of those things. So, like, I
Even
understand.
just to add this, like vitamin D is highly related to cholesterol, right? So you
Right,
need
exactly.
sunlight to make vitamin D, but vitamin D is made through cholesterol. So we were just talking about some before this. Like, how important is it to, there's a myriad of number of reasons why light is important, but even just for getting cholesterol out of the bloodstream and into vitamin D, if you have low vitamin D, that could also be related to cholesterol in some way.
Exactly. Oh, sorry. Since we're about to talk about statins, I think earlier I said accidentally that statins mimic mevalonic acid. They actually mimic HMG CoA. So before it goes through the HMG CoA reductase, I apologize. That was a
Okay.
mistake.
Okay. So you brought up a great point about the high cholesterol not being shuttled through into making hormones. Why do you think statins don't just tank hormone production? Because they seem to have like a possibly significant effect on testosterone, but it's debated. It's not like a clear hypogonadism is induced after the induction or after the taking of statins.
Okay, so my understanding of statins is that they primarily work on cholesterol synthesis in the liver. So if it's still working on just cholesterol synthesis in the liver, and I could be wrong about that, but that's my understanding currently, then you would still have those alternative sources of testosterone, et cetera, synthesis, because like it would be the same thing. Like, why do people not become like, why do they not get like Addison's disease, for example, because they're no longer making cortisol when they're on a statin. So I think that is most likely the reason why, is because of the effect more on the liver versus the gonads, the adrenal glands, etc.
And as we discussed before, you'd probably see an upregulation in the absorption then, right? Because the liver's not making so much.
Exactly. That would be the other thing too.
Okay.
But in that case, you would, if people are like tracking their labs, they would see that then, right? Well, I don't know. They might not necessarily see that because the body might be absorbing X amount from the food, and then because it's like lower on the cholesterol like number overall, it's just like sending whatever cholesterol has available to the gonads, etc., to like make the hormones, and so you don't really see like the fluctuations from like food. You would have to be taking like constant blood measurements to see like, okay, am I absorbing this? How much am I absorbing? How quickly is it going to the adrenal glands, like, etc. So yeah, that's probably why.
Cool. Did you want to discuss anything about cholesterol and its relationship to bile?
I mean, I think the big thing is that most of the bile acid is made. I don't know the percentage, but it's made out of cholesterol. Like that's again back to the HDL part, when the HDL brings the fats, the cholesterol and triglycerides back and stuff like that. It can dump the cholesterol into just the intestines, become feces, or to make bile. I think that bile is a kind of a big missing piece for a lot of people, whether it's they're making too much, or they're not making enough, or they're releasing at the wrong time, or like obviously people that have had their gallbladders taken out, that's a big problem too. So, and also like the bile in the small intestine, and making sure, because that's where it's obviously dumped, and making sure that the small intestine stays clear of things like bacteria and fungus and stuff like that. I think that's an important piece. Is there anything more specific that you want to talk about with bile?
No, I was just curious if there was anything that you wanted to like mention in that relationship, but I know they are related. It doesn't seem like, in terms of the grand scheme of high cholesterol, bile is a big factor there.
It would be interesting to know, like, the people that have high cholesterol, do they produce more bile or less bile? I don't know that. That would be, I think, an interesting topic to explore. And then, so like, if they have high cholesterol and they produce less bile, like why is that happening? I think that again goes back to what I was talking about with HDL, that people will just say, well, the HDL is the good version because it brings it back, and then the liver just gets rid of it. But it's like, but what happens if the liver can't get rid of it anymore? So kind of back to what we were talking about there.
Mm-hmm. I mentioned earlier that low cholesterol also seems to be indicative of a number of diseases, including autoimmune and a lot of cancers. So if you have low cholesterol, essentially it's kind of like a lot of the issues with these cholesterol studies, they don't like, or people that are parroting them don't take into account all-cause mortality. So it's like, yeah, your cholesterol is low, but you're just dying of something else at the same time. Anything you want to add to that?
No, I know last time we were talking about, I think in the 90s, there was an autism researcher that they realized that a fair amount of people with, um, the very far end of the autism spectrum. So we're talking about, the children that are in like helmets and stuff because they're like banging their head against the wall, nonverbal, like all of that stuff, that they noticed that they were low in cholesterol and they started giving them cholesterol and they noticed an improvement. So, again, I think that just goes to show that um, in the body, like I always see things in terms of like equilibrium and thresholds, right? Because like just because something is good doesn't mean more is good. Just because something is quote unquote bad doesn't mean like even less or like, you know, um, obviously in the case of like arsenic and stuff, like that's a different conversation. But like, with cholesterol, like just because it's seen as like a quote unquote bad thing because of like LDL and stuff like that, that doesn't mean like rock bottoming it is a good thing. So I think that's all I have to really say about that part.
Cool. And then just to cap this off, couple cholesterol biomarkers that people look at: total cholesterol, which is the sum of HDL and LDL. I don't think VLDL or ILD. I guess ILDL would be included.
Yeah, I don't think that. Let's see here. I don't. Yeah, in total. I think total cholesterol at this point in time, I think most of them are just calculations off of each other, right? Unless you actually get the actual physical measurement of VLDL, which you can get nowadays, and like the particle size and all of that stuff. You can get that information.
That is cool.
Yeah, but most of them are just like GFR for the kidneys. Like a lot of these things are just calculations off of using certain equations and then based off of like other labs that are drawn. So that's the one like issue with labs is kind of take it for what it's worth because we like learn more and more and realize that maybe there's actually something more here that we didn't realize, and so we were telling people that something was really high when really it was fine. And
yeah. Okay, so above 240 is said to be high for total cholesterol. LDL above 160 is said to be high. HDL below 50 for women and below 40 for men is said to be low. And then serum triglycerides, which is the amount of fat in your blood, is above 200 is said to be high. Those are slightly different but very related. Is there any disagreement there? You think that's a pretty good number to be within those ranges?
I think the average ranges are there for a reason. But again, I wouldn't necessarily say that if you're over that cholesterol number that you should take a statin, right? Because again, that's not really addressing the problem because I imagine, or I would, probably bet that like if you're over that much in cholesterol, then like you probably have, your fasting blood glucose is probably starting to creep up. Your fasting insulin is probably starting to creep up. Your if you were to run lactate, you'd probably see that that's starting to creep up. So, and the fatty acids in serum, like all of these things, I think if you were to actually run them, you would see that they are high as well or starting to creep up as well. So, I think that lab values are good because they basically kind of compare you to the norm, but that doesn't mean that you immediately jump on a medication. I think that tells you right there that, okay, we need to start looking at some of these lifestyle things, the LEA considerations, because again, like we've discussed before, I definitely believe that you can be in LEA or a Breda state and be overweight, right? It's just like you're not making sufficient ATP at the cellular level, even though you have all of this fuel available. So, I think the numbers are fine, but it's just something to compare yourself off of.
Yeah. Cool. I think that really wraps it up. If you are struggling with cholesterol issues, whether low or high, essentially the answer is kind of the same. Try to clear up that metabolic pathway, build your metabolism, get enough micronutrients in, get in the RDA, tracking chronometer if you need, and slowly build up over time without gaining weight, which we have discussed ad nauseum and will hopefully continue to discuss.
Yeah. If anything, like high cholesterol is, I almost see it as like we're just making way too much acetyl-CoA. Like, and the body's just like, I gotta get rid of this somehow. So let's go to cholesterol. Where like low cholesterol, it's like we're just not making enough acetyl-CoA. Obviously, more nuance like as you're going down the path, but like let's just start with the first thing right here, and are we making enough of that or too much of that? And I think going from there, if you that will help to guide you.
Awesome. Any last words?
No, I think that was it. Thank you. This was a good conversation. If someone has like more thoughts or anything that we were kind of like stuck on, if you like want to put it in the comment section and then we can like go down those rabbit holes and stuff, that would be great. You know, I think the other thing too is like back to the bile piece. So once cholesterol makes I believe the bile acids, then they get conjugated with glycine and taurine. And so that's where you get the basically like the TUDCAs and the GUDCAs. If I remember correctly, the TUDCAs only account for like 20%, and the GUDCAs, so the glycine ones, account for like 80%, which I always found interesting because most people push TUDCA. I don't even think you can get GUDCA.
I've never even heard of GUDCA.
Yeah, the glycine one.
Yeah.
Yeah, but again, though, glycine, I understand everyone has a love affair with taking glycine as a supplement, whether by itself or with magnesium, or obviously getting, you know, collagen, gelatin from animal products. But again, we make glycine from carbohydrates. So, you know, the reason why I keep bringing up carbohydrates is that it seems to be the big one that's like demonized nowadays. So, yeah, that's why. But so, you know, I think carbs are crucially important in order to make sufficient glycine and all of these other things like G6P, etc., for pentose phosphate pathway. And yeah, so that's all I have to say.
Awesome. I think next time we will be doing a Q&A that will be taking questions from Instagram and probably YouTube too. So if you have any questions, make sure to submit those and we'll post that next week. Thanks, everyone. Thanks, Kathleen. See you guys next time.
Thanks, Tyler.